Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Atia Sakinah binti Masran, metric number 1171460. My supervisor is Prof. Madya Dr. Azwani Sofia binti Ahmad Khiar. My proposal title is Effect of the Ethylene Carbonate EC to the Conductivity Cytosine Gelatin Doped by Sodium Polychloride Polymer Electrolyte. This is my planned talk. I will talk about introduction, problem statement, significant research, objective, literature review, methodology, expected result, and Gantt chart. Okay, for introduction, polymer electrolyte. Polymer electrolyte is electrolytic material that offer many advantage. Polyelectrolyte also is a macromolecular system that transport charge. It's in energy conversion and storage device such as batteries and fuel cell. Polymer electrolyte also have two types, a liquid and solid polymer electrolyte. As we know, our phone cell use liquid lithium ion in the batteries. So liquid lithium ion has its disadvantage, such as first, low thermal stability. Low thermal stability, if the temperature is increased, it will damage the batteries of phone. Second is non-biodegradable polymer. Non-biodegradable polymer means it will not break down in biological process. Third is lacking in safety. Lacking in safety, easy to exploit. Like on 17 June 2019, a Malaysian man severely burned after his phone exploded, causing by overheating. So a researcher have a better alternative to replace the liquid lithium ion is to replace it with solid polymer electrolyte. But solid polymer electrolyte have its deficiency. Its deficiency is low conductivity. So to increase the low conductivity, in my significant of research, I will improve to increase the conductivity cytosine gelatin, which cytosine gelatin is solid polymer electrolyte doped with sodium perchloride and HClO4. I will improve the conductivity of the solid polymer electrolyte. In the objective, first, to produce thin film of cytosine gelatin blend doped with sodium perchloride and HClO4 and ethylene carbonate EC polymer electrolyte by cast technique. Second is to investigate the effect of ethylene carbonate to the conductivity cytosine gelatin doped with sodium perchloride and HClO4. Literature review. First is natural polymer. Natural polymer is biopolymer that come from organic macromolecular. Macromolecular means from plants and animals. It's also not expensive, biodegradable, which means can break down in biological process and readily available. For example, cytosine, we can get it from prawn shell. So, other example for natural polymer is silk, polysaccharide, cellulose, and protein. For cytosine is produced by the diacetylation of chitin. It's a natural and biocompatible polysaccharide. It's composed from long biopolymer chains. Gelatin is one of the natural polymer, or one of the example for natural polymer. It's used in food, pharmaceutical, cosmetic and photographic industry. It also good conductivity in room temperature. They have some research about the gelatin conductivity. They got around 10 to the power negative 5 to 10 to the power negative 4 Siemens per centimeter. Then next is plasticizer. Plasticizer is a non-volatile organic substance. It will use as additive in polymer industry. Other function of plasticizer is to increase the electric conductivity. Methodology. First, Cathosan and acetic acid will still until it become Cathosan and acetic acid will stir. Gelatin and distilled water will also stir continuously until it become homogeneous. Stir continuously using magnetic stirrer until the solution dissolve completely. Then solution of Cathosan and solution of gelatin will added with NaClO4 and ethylene carbonate. After that, the sample of characterization will prepared by the process of the thin film. Sample of characterization will prepared by the process characterization using electrochemical impedance spectroscopy. Then expected result from this research is: first, thin film are produced. Second, high conductivity in range 10 to the power negative 5 to 10 to the power negative 4 Siemens per centimeter. Third is ethylene carbonate influence the increase of ionic conductivity. This is my Gantt chart. October to November, the production of thin film of Cathosan and gelatin of NaClO4 and ethylene carbonate EC as the polymer electrolyte bypass technique. On December, the investigation on the effect ethylene carbonate EC to the electrical conductivity polymer electrolyte. January 2021, determination the increase of electrical conductivity by adding ethylene carbonate to the polymer electrolyte. On Feb 2021, data analysis and comparison, final report and article submission for publication. This is my reference. That's all. Thank you.